so remember, each problem is going to be worth 8 points, yeah? So what you want to do is at least come up with the equation. Okay, now I'm going to give you the chart to draw, but see, every year there's students, they just fill in the chart and they plot those points, but you're not going to get anything for that, okay? You need to come up with the equation first. That thing, the chart is just there to tell you how the particle is traveling on the graph. So if you don't have the graph to begin with, yeah, anybody can plug in points and plot those points, but you gotta plot it on the right graph. Okay, what do I do here? Half angle. Now remember, tangent squared means the same thing as this squared. So tangent theta over 2. Are there 3 identities? Which one do you think is going to be more useful in this one, since that's the cosine one? The one with the cosine. So what's the identity for tangent theta over 2? Plus or minus square root?
1 plus cosine.
Good.
1 minus.
1 minus cosine theta all over 1 plus cosine theta. And then you got to square it, right? Because squared, right? And then when you square the radical, the plus or minus, no more. So you get 1 minus cosine t all over 1 plus cosine t. And then if you substitute in x for cosine t, what do you get? You get y equal 1 minus x over 1 plus x. There, that's 4 points right there. Half angle identity, just like the vector one, right? Okay, now, you gotta draw this graph. You wanna get more points, you gotta draw this graph, and then you gotta indicate how the particle is traveling on this graph. So this might be a good review. How do you graph rational functions? What are the 4 things that we learned? X-intercept, Y-intercept, vertical asymptote, and then horizontal or slant asymptote, right? Okay, let's see if we remember. I'll tell you right now that you are going to get rational. I don't know, at least one of them is going to come out to a rational function. Okay, x-intercept, what do you look for? When the numerator is 0, what makes the top 0? 1. Y-intercept, plug in 0 for x, and you get 1 over 1. 1. Vertical asymptote is when the denominator is 0.
Negative 1.
Okay, so x equal negative 1. And then for horizontal asymptote, if the degree of the top and the bottom are the same, kind of like what we did, it's erased.
1.
You look at the coefficient, so negative 1 over 1 is negative 1. So y equals negative 1 is the horizontal asymptote. What would happen if the degree of the top is bigger?
Slant.
Then you get a slant asymptote, and to get that you gotta divide, right? So the graph gotta be down here. How come it can't be up here? Because if it were up here, it would cross the x-axis, but there's no x-intercept there. And none of this up, I'm just gonna go around the x-axis. Don't ever do that. Okay, and then of course, if it's down on this side, how come I know it's up on this side? Well, of course, got the intercepts there, but come on, remember? If the power is odd, that means it's gonna go opposite ways, right? And then in the numerator, if you have an odd power, then it goes through the x-intercept, yeah? So see, since it's exploding down on this side, it's gonna explode up on that side. And then it's gonna go through the x-intercept and then get closer to the horizontal asymptote. Okay, now, how does the particle travel on this? I'm gonna give you a chart over here. So T, X, Y. Because some of you still have a hard time, like, what do I need to plug in? Well, I'll tell you what to plug in to make it easier for you. And like I said, you don't get points for this. This is just to help you. Okay, here are the original equations. Okay, plug in 0. What do you got? 1, what? 1, 0. Plug in pi over 4. Root 2 over 2. Uh-oh. I don't know if you can do that. Tangent pi over 8. Nah. I don't know. Tangent pi over 8, you don't know that. That's it. I don't want you to use half angle to figure that out. So maybe we shouldn't put that out there. Maybe we should do pi over 3 then. pi over 6. Let's do pi over 6. Pi over 6. Really? Cosine of pi over 6? Root 3 over 2. What is pi? Oh, you got pi over 12. Okay, that's a bad one. Pi over 3 then. You know what? Maybe just these 3 might be enough to draw the graph. I don't know, I just thought of this in the car when I was driving this thing. Okay, what happens when you plug in pi over 2? You get 0, 1. Oh, see, that's not bad. And then plug in pi. Negative 1. Tangent of pi over 2 is undefined, huh? Okay, so what's happening? The particle starts here, it goes over here, and then what does it mean when it's undefined? It's going to explode out somewhere, so it's going to go like this. I think that would be good enough for now. We don't have to think anymore, yeah? Like, what about on the opposite side of pi? Anyway, this is what I think of when I'm driving to school and driving home. See, make problems for you guys. Oh, I want you guys to do half angle. But now since I showed you that, I'll make you do double angle. Okay, whatever. And of course, I like the one where you know how the graph gets closer and closer to the point, but it never gets there. Make sure you draw the open circle now. Because I'm not going to see you until the test, right? And what are the other problems I told you that are going to be on the test? There were 3 other ones. The matching one, match the graph with the equation, find the distance between a point and a line. There's another one on the practice test, right? No, that was your homework, right? So did you do it? Okay, that problem is on the test. And what was the other one? Oh, where does a line intersect like a graph? I'm going to give you like 2 points, and I'm going to ask you, where does the line intersect? It's not going to be a plane though. Maybe it'll be a sphere or ellipsoid, paraboloid or something. I want more than one answer, that's why. I don't want, a plane is just too simple for you. All right. Okay, so we go on to the next chapter. What the heck is combinatorics? Combinatorics. Basically, it's permutations and combinations. Now, the other classes told me they learned it in Algebra 1. Is that true? Because Algebra 2, you guys didn't have time to do anything, right? I guess we're going to catch up right here. That's what this class is for. Catch up on everything that you didn't catch up before you go to calculus. So the first thing is, what is the difference between a permutation and a combination? You guys remember any Algebra 1? Or even pre-algebra, you might learn this. Okay, by definition, a permutation is an arrangement of objects. It's an arrangement of objects, which means the order is important. Does that sound familiar? The order is important. In other words, like ABC is different from BCA because it's an order. So what are things where the order is important? Like when you make a word, right? Because isn't cat different from act? You don't go, here, come here, act, come here, act. Yeah, so anytime the order is important, it's a permutation. What else is the order important? What about a number? Is 231 the same thing as 123? No, so whenever you make a word or a number, or whenever you see the word arrange, how many ways can you arrange people in a row? That's what they like to do on the SAT. So if you see the word arrange, you know it's a permutation. A combination is when the order is not important. By definition, it's a collection of objects. So things that are combinations would be like committees. When you form a committee, does it matter what order you're on the committee? No, you just have a committee. Like, is this committee the same thing as that committee? Yeah, you have the same 3 people. It doesn't matter what order they're in. What about cards? When you play cards. Now, you might put the cards in a certain order when you're playing cards, but does it matter? No, like if you play poker, if you have 3 2s and 2 5s, you got a full house, right? It doesn't matter what order you put it in. So committees, cards, those are perfect combination problems. So today we're gonna start with permutations. So all of these problems here are permutations. The orders will be important. And then the next worksheet will be combinations. The order is not important. And then we're gonna learn some other stuff, the high level stuff. So before I even talk about that, okay, so when you read a problem, the first thing you gotta ask yourself is this a permutation or a combination? And then you gotta ask yourself, when you start doing the problem, should I do the problem directly? Or should I compute the complement of that and subtract it from the total? What do you mean by that? Well, you'll find out soon. And then after that, you gotta ask yourself, well, I have like several numbers here. Do I add them or do I multiply them? These are questions that are gonna come up over and over and over. So the first question is easily answered on tonight's homework because they're all permutations. You don't have to worry, okay? So what we're gonna do tonight is we're gonna use what we call the multiplication principle. Which is, if one event can occur in m ways, and an and, see the word and there? And implies multiplication, whereas the word or implies addition, yeah? If one event can occur in m ways, and another event can occur in n ways, the number of ways they can occur together, that's another key word, is m times n. For example, I'm pretty sure you did this problem in elementary school. Was Mrs. Derby, who went to Eli kindergarten? Was Mrs. Derby teaching then? She used to teach them like logic and probability, you know. Did you guys learn it? You guys probably just forgot. Anyway, suppose you have 3 shirts. Does that look like a shirt? I think I showed you if you were in my SAT prep class. Let's say you have 3 shirts and you have 2 pairs of pants. Doesn't it look like pants? Too bad it is. If an outfit consists of 1 shirt and a pair of pants, how many different outfits can you make?
6.
Well, well, the easy way would be, how many choices do you have for a shirt? How many choices do you have for pants? Are you gonna wear them together? Yes, multiply them 6. See, that's an example of the multiplication principle. But the way you would do it in elementary school would be like this, yeah? I can wear this shirt with this pants or this pants. This shirt can be worn with this pants or this pants. And this shirt could be worn with that pants or that pants. And how many is that? 1, 2, 3, 4, 5, 6, right? But then what if you have 500 shirts and 250 pants? You're gonna keep drawing those lines and count them all? No! That's why we wanna learn this, so we don't have to do that. We wanna learn like things that can help us make it easier. And then what happens now if you have a hat? Let's say you have 4 different caps at home. Does that look like a cap? So what if an outfit consists of 4, a cap, a shirt, and a pair of pants? How many different outfits are possible? Well, how many choices do I have for a cap? 4. How many choices do I have for a shirt? What about a pants? Am I gonna wear them together? Multiply them so there's 24 different outfits you can make. This is called the multiplication principle. Now, whenever you do permutations, so it just depends. Like if you actually did problems in your Algebra 2 book last year, your book would have given you this formula. I don't know if your book wrote it like that or your book wrote it like that. Did anybody take a peek? Anyway, when you see a capital P, that means permutation. This is the permutation of n things taken r at a time. After the test, the next class, we're gonna do this. You can probably guess what that is, right? That's the combination of n things taken r, but you're not gonna have that tonight. Okay, so this is how your book would teach it. Let's say you have 8 people. Alfredo, Bernardo, Carlos, Diego, Eduardo, Fuego, Guapo, Hidalgo. Okay? I want to pick 5 of them and arrange them on a bench. That's what I wanna do. I'm gonna pick 5 of them and arrange them. See, I use the word arrange, that means permutation. So that means, so your book, this is the way your book would teach you. It's a permutation. How many total people are there? 8. And how many am I gonna select to arrange? 5 of them. Of course, then you would have to know the formula. Anyway, this is the formula the book tells you. It's n factorial all over n minus r factorial. You guys know what well, yes, we did this. Remember when we did the binomial theorem? Remember I had to teach you this? So yes, you guys know what factorial is. And let's just do a review. What is 0 factorial? 1. Because sometimes you're going to end up with 0 factorial in these formulas. You need to know what it is. So if I apply the formula to this, what do you got? 8 factorial over 8 minus 5 factorial. 3 factorial. Okay, now simplify it.
8 times 6.
No, the problems that I'm going to give you on the quiz and the test, all the answers will be less than 1 million, so you don't have to worry about using a calculator. But if the answer ever goes more than 1 million, then you can use your calculator. Okay, what does 8 factorial mean? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What is 3 factorial?
3 times.
3 times 2 times 1. Let the canceling begin. No. So all you have left is that. And then can you guys multiply that number? Okay, so here's the rule on the quiz and test. If you write down the formula, you can get 3 out of 4 points. The last point is, can you compute that? I hope so. Everybody here went to elementary school. Like, what would I do if I had to multiply this out? I would do, this is 20, right? What is 20 times 6? Really? 120. And what is 8 times 7? 56. So basically, you just gotta multiply 56 times 12, right? 56 times 12, 2 carry 1, 6, 5, 2, 7, 6. So the answer is 6720. Woo! That's how you get the 4th point right there. So if you had 8 people to choose from, and you're gonna arrange them in a row or, on a bench or something, there's 6,720 ways of doing it. Now that's the way your book would teach you, using this formula, but I don't like that. I don't like to use that formula, because sometimes, the easy problems, easy, but then we're honors, we're not gonna get easy problems. So I think the multiplication principle is gonna be better for you. So just remember, anytime you have a permutation, use the multiplication principle. So to me, this is the easiest way. We're gonna arrange them on a bench or whatever, on 5 seats, whatever. Here are the 5 seats. Here are the 8 people. How many choices do I have for the first seat?
3.
Yeah, you can pick any of the 8 people. Once that person sits down, how many choices do I have for the second seat?
7.
Once that person sits down, how many choices?
7.
And then?
5.
And then?
4.
Then multiply it. Isn't that the same thing as what we got here? Except it's more understandable, yeah? So believe me, use the multiplication principle. On the easy problems, yeah, it doesn't matter, but I'm telling you, on the hard problems, it's way easier to do this. So what I'm gonna do now is we're gonna go over lots of different examples so you can see. So what you gotta do is, you gotta kind of categorize things, like, when you get this kind of problem, you do this. When you get this kind of problem, you do that. So that's why you have to do a lot of problems. Okay, why don't we keep with this thing here? So I have 8 people: Alfredo, Bernardo, Carlos, Diego, Eduardo, Fuego, Guapo, Hidalgo. Okay, how many ways can you arrange them into 5 seats? Okay, that's the answer there. But then if I put a restriction on it, then it becomes harder. How many ways can I arrange them into 5 seats if Carlos must sit in either the one of the n seats here? So Carlos, he either has to sit here or here. Now once you put restrictions on, then you gotta start thinking. So what I like to do is I like to do a specific case and then multiply by the number of cases. So let's do a specific case. What if Carlos had to sit there? How many choices would I have for that seat if it's Carlos?
1.
1, because that's Carlos, right? Now, I've got 7 other people. How many choices? 7, 6, 5, 4. And then you multiply these numbers, right? Because they're occurring together. Carlos sits in the left seat? No, he can sit on either one of the end seats. So now you multiply by the number of cases, which is 2, because he can either sit here or there. Now, if you don't like this thing I'm teaching you, then what you gotta do is you gotta do all the cases. You gotta go, okay, here's the other case, Mr. Park. Carlos sits here. That's 1. And then 7, 6, 5, 4. Can you see it's exactly the same numbers? And then you add these two. Now, why would you add these two? Because these two are, what's the word we like to use?
Independent.
Mutually exclusive. Anybody here taking AP stats? Mutually exclusive? So when things can, mutually exclusive means they cannot occur at the same time. That's what they mean. That's when you add. But see, why would you want to add when you can just multiply? Especially instead of adding the same thing 8 times, wouldn't it be better to just multiply by 8? Yeah, multiplication is just repeated addition. Okay, so you gotta remember that now. So when you get more difficult problems, do a specific case and then multiply by the number of cases. Okay, let's try another one. Here are the 5 seats. How many ways can these 8 people be arranged in these 5 seats if Alfredo and Bernardo have to sit together? That's the restriction. Alfredo and Bernardo have to sit next to each other. Okay, so let's do a specific case. What if Alfredo and Bernardo sit in the first 2 seats? How many choices do I have? 2, either Alfredo or Bernardo. Once he sits down,
1.
then 1. And then you got what?
6.
You got how many other people?
6.
6 other people? So 6, 5, 4. Okay, that's easy. The hard part is figuring out how many cases there are. So how many cases are there? Well, Alfredo and Bernardo could sit here. What about there?
Yes.
What about there? What about there? So how many cases is that? 1, 2, 3, 4. So you times by 4. Okay, let's do another one. Like I said, you just gotta keep on looking at examples. Okay, how many ways can I arrange them if Alfredo and Bernardo have to be separated by at least 1 seat? They cannot sit next to each other because they don't behave. Shannon again. Okay, so let's do a specific case. What if Alfredo and Bernardo are in seats 1 and 3? Do a specific case. Okay, this is Alfredo and Bernardo. How many choices? 2 and 1, and then now 6, 5, 4. See, that's the easy part. But now, how many cases are there? How many cases are there where they can be separated? Well, couldn't they sit in seats 1 and 3? What about 1 and 4? What about 1 and 5? What about 2 and 4? 2 and 5? 3 and 5? Did I catch them all? So how many cases is that? 1, 2, 3, 4, 5, 6. Boom! That's not that difficult, Mr. Park. Or, another way you could have done this problem. How many ways can Alfredo or Bernardo be separated by at least 1 seat? Well, now, like I was telling you before, when you see a problem, you gotta ask yourself, well, should I compute that problem directly like I did here? Or maybe I can do the complement. What's the complement of 2 people cannot sit next to each other? What's the complement of that? Like the opposite of it?
2 people.
They sit together. But didn't we already do this problem here? This is how many ways they can sit together. So instead of doing this, what could I have done then? This is how many ways they could sit together. So if I want to find how many ways they can be not together, you simply subtract it from the total. Now, didn't we do the total? Where's the total? Right here. Isn't this the total? How many ways 5 people can be arranged? I mean, the 8 people. So you simply subtract that from the total, which is 8, 7, 6, 5, 4. Of course, these are all multiplied, yeah? Can you see that they're the same number? Or do we have to multiply it out? Okay, I'll tell you what. You know, when you get to the quiz or test and then you gotta compute large numbers, don't compute this and then compute that and subtract. How about like factor? Now look at this and look at this. What can be factored out?
6
654, right?
Eight.
Right? No, 654, 654, and you can also factor out another 4. Or you can factor out an 8 even, right? Okay, so you want to factor out 8 then? So 6548, 6548. So what's left if I factor it out? 65487 minus 1. So that's a 6. Now can you see they're equal?
Yeah.
Look, 654, look, 654, and then we got 6 times 2. Wait, something's wrong here. How come it didn't come out? 654, 6 times 2. See, because I know this is correct. What went wrong? Is this the total? Is this the actual total? Yeah, that's the total. So if I factor out a 654, what, and an 8, what's going to be left? 7. 654, 8, you get a 1. That's correct. Something went wrong. Nobody sees it. Anyway, it's supposed to come up. I'm not sure what happened there. Okay, anyway, we're going to move on because we need to look at, oh my goodness, we're going to get 12 minutes left. We got so many more examples to do. Okay, let's do numbers now. Let's do a number. Okay, here are the digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's look at a 3-digit number. So when you make a number, the order is important, right? How many 3-digit numbers can you make using the digits here? How many 3-digit numbers can you make? Period. How many choices do I have for the first digit? 10. No. How come it's not 10? It's 9. That's right, it's 9. How come 9?
Yeah.
Because 0 cannot be the first digit. Because if 0 is the first digit, then it's a 2-digit number. Come on. Okay, how many choices do I have for the second digit?
9.
No, 10. You can pick any one of the 10. Wait, did I say you can't repeat?
Oh.
If I don't indicate that you can't repeat, then you gotta assume you can, right? Because is there such thing as a number 444? Or no, I don't believe it exists. Yeah, you have to assume the obvious. How many choices do I have for the third digit? 10. Okay, now multiply them easy, 900, right? Okay, now let's put a restriction on. How many 3-digit numbers can you make where the digits don't repeat? Now, how many choices do I have for the first digit?
9.
9, okay? Once you use that one, you cannot use it again. So how many choices do you have for the second digit?
9.
9, because now you can use the 0, right? And then how many choices for the third? You can't repeat. 8, and then I can trust you to multiply out those numbers, yeah? I hope. Okay, so here we go. How many 3-digit numbers are odd? So how many 3-digit numbers are odd? How many choices for the first digit? 9, because again, 0 cannot be the first digit. Now, if we want an odd number, how many choices do I have for this? 5. It has to be either the 1, 3, 5, or 7, right? So you got 5 choices. How many choices for the second digit?
10.
Can be anything. 10. Easy. Multiply it out, you get your answer. Okay, but now, how many odd 3-digit numbers can you make if you cannot repeat? No repetitions. So in that case, you probably want to fill this one in first because you got to make it odd. So how many choices? 5. Now, whatever number you put here, you cannot use it again. So how many choices do I have for the first digit? Because the first digit cannot be 0 either.
4.
Can't be this and it can't be the 0. So you got 8. Okay, how many choices over here? Now you can use the 0. It could be anything except the one you had here and the one you had here.
8.
So you have 8, and then just multiply those numbers and that's your answer. Okay, now here's the big one. how many 3-digit even numbers can you make without repeating digits? No repeating.
5.
Okay, if this is gonna be an even number, what?
4.
You got 5 choices, that's 0, 2, 4, 6, or 8, okay? Okay. You think you're good, yeah, 5. Now that, so whatever I used here, I can't use it anymore, so how many choices do I have for the first digit?
8.
Are you sure?
No.
Why not?
I don't know.
Well, if this was a 0, how many choices would you have here?
8.
You would have 9 choices, right? But if this wasn't a 0, well, like if it was the 2, 4, 6, or 8, then how many choices would I have here?
8.
Yeah, so then what do I do, Mr. Park?
8.5.
Because if this is a 0, and then in the other case is 2, 4, 6, 8, it makes a difference. So what do you do then? You gotta make 2 mutually exclusive cases. So what you gotta do is you gotta do one case where the last digit is 0, and another case where the last digit is either the 2, 4, 6, or 8. Because that's gonna change all the rest of the things. So if the last digit is a 0, there's only one choice, right? It's a 0. How many choices do you have here? You can't repeat. 9, and then? Okay, good. Now, if the last digit is 2, 4, 6, or 8, then how many choices do you have?
4.
4. Okay, let's say you pick the 2. Let's say you pick the 2. How many choices do you have for the first digit now? It can't be a 0, but it can't be the 2.
8.
You got 8. How many choices do I have for the second digit? Because now you can use the 0.
8.
You got 8. And then once you multiply this out and multiply this out, what do you do with these two numbers? Why do you add them? Because these are 2 mutually exclusive cases. They cannot occur at the same time. See, if they occur together, you multiply the numbers. If they cannot occur together, then that's when you add them. So like I said, if you write down the formula, you're gonna get 3 out of 4 points on the quiz or test. And then of course the last point is, can you compute it? Okay, what time is it? I gotta look at that. Something went wrong here. I gotta figure that out by next time. All right. Oh, here. How many 3-digit numbers contain at least 1 7? How many 3-digit numbers contain at least 1 7? Now think about how you're gonna do that problem. We got 5 minutes to do it. What does at least 1 7 mean?
Either can be more than
You could have 1 7, you could have 2 7s, or you could have all 3 of them 7s, right? Well, so Mr. Parker, I'm gonna make 3 separate cases then. Yeah, that would be one way. So you could make 3 cases, so 1 7, but then if you pick 1 7, you got 3 cases because the 7 could be here, here, or here, right? And then what about 2 7s? Well, you could have the 2 7s here, or the 2 7s could be there, or the 2 7s could be here. So that one would have 3 cases, and then of course all 3 7s, there's only 1 case, right? That seems kind of complicated, Mr. Park. There's gotta be a better way. Yes. So that's why I keep telling you, when you come across a problem, you gotta ask yourself, is it better to compute this thing directly, or should I do the complement, like the opposite of it, and subtract it from the total? What is the opposite of a number contains at least 1 7?
no 7.
It contains no 7s. So maybe it's better to compute how many numbers have no 7s, and then subtract it from the total. Well, let's see. Because we already know, if you do it directly, it's gonna take a long time. Okay, how many 3-digit numbers contain absolutely no 7s? How many choices do I have for the first digit?
8.
Cannot be the 0 and it can't be the 7, right? So you got 8 choices. What about the second digit?
9.
It just can't be the 7, and it didn't say anything about repeating, so that means you can repeat. And then how many choices for the third? 9. So that's how many numbers have no 7s. So all I have to do is subtract that from the total then, right? How many 3-digit numbers are there? I think we already did that on the other side. Remember what it was?
900.
How many, or let's do it all over. How many choices do you have?
9.
9, 10, 10, there's your formula, you got 3 out of 4 points already. So, there's so many things you gotta think of when you're doing this problem. Permutation or combination. Should I compute it directly or do the complement minus the total? And then, when I have all these numbers, should I add them or do I multiply them? You gotta constantly be asking yourself that. Okay. Yeah, these are all fun problems right here. Okay, the bell's gonna ring in 2 minutes.